welcome to Cloud Expert channel. I hope you all are safe and doing fine. Today I would like to talk about Amazon DynamoDB Accelerator or DAX and different caching mechanism that DAX supports. Without further delay, let's get started. So first, I would like to explain why caching is so important. Let's say your application has one application load balancer, what is front-ending all your application load, followed by one EC2 instance. You have your application in that EC2 instance and a DynamoDB table that's serving the data for the application. And as you know, DynamoDB is Amazon's NoSQL database offering. For every read and write, DynamoDB requires read capacity unit and write capacity unit. Let's say your EC2 instance is deployed in an auto-scaling group. So whenever there is extra load, EC2 instance will be automatically scale up or scale down. And on the same time, to handle the extra load, what you have done, you have provision DynamoDB read-write capacity. Maybe you could have do schedule scaling, or maybe you could have do auto scaling, or maybe you have a provision throughput, or you do not have a auto scaling on the read write capacity unit. Now let's see some real use case. So let's say your application load balancer is sending the traffic to EC2 instance, and EC2 instance is sending the traffic to DynamoDB table. DynamoDB table processing that request and sending the data back to EC2 instance, and then the application inside EC2 instance is sending the data back to user via application load balancer. In normal case, if the application load is moderate and your DynamoDB has been provisioned with sufficient read capacity unit, your application will work seamlessly. Your user will not face any challenges and the application will work smooth for them. But let's say suddenly the load increased. Your application load balancer is sending more and more traffic to your application. The auto scaling group, what it will do? It will increase the number of EC2 instance to cope up that load. And now your DynamoDB table will get request from all those EC2 instances, and as a result the request will be overwhelmed the DynamoDB table. Again, if your DynamoDB table has sufficient read capacity unit, it will support all the read and your application user will not face any issue. But one thing to be remembered here, the more and more read and write capacity unit you are going to provision, your DynamoDB cost will also increase. Your monthly bill will also increase. And for each and every request, no matter if your user is requesting for the same data again and again, then also we are going to DynamoDB table to get the data. Obviously, to support this kind of scenario, you have to provision a considerable amount of read and write capacity unit. For read capacity unit, for write capacity unit. Let's say another one architecture, serverless architecture, where I have one API gateway and I have exposed some RESTful API with the help of a Lambda function. And to serve that request, Lambda function needs to query the data from the database. Now, API gateway will also send traffic to DynamoDB table via Lambda function. Now here you can understand your DynamoDB table is really loaded with read request. Although user is requesting same data again and again, then also we are invoking the database, right? Just to remove the dependency or just to remove the similar reads from DynamoDB table, what we can do, we can introduce one layer in between your application and DynamoDB, or maybe Lambda function and DynamoDB, what it will do, it will serve that same read from that cache instead of going back to DynamoDB table. Now, for that purpose, AWS has offering called Elasticache, and it has two different flavors, Redis and Memcached. Redis and Memcached has both different use cases. So for the time being, let's say we have used Redis for the caching layer. So what your application will do, application will invoke Redis or read the request from Redis instead of going to DynamoDB table. And Redis, if the data already exists in the Redis cluster, it will be considered as cache hit. It will serve the traffic or read request from the Redis cluster instead of going to DynamoDB table. But if the data is not available in Redis cluster, it will go to DynamoDB table, read the data, populate the data in Redis cluster, and send the data back to your application. So now you can understand introduction of that caching layer reduced a significant amount of load from your DynamoDB table if user is requesting same data again and again. If your user is requesting different data every time, there is no similar read request, then obviously this architecture is not that much useful, because if you have to go every time to DynamoDB table, you have to plan your read capacity unit, But if you have a read heavy application and your user is requesting same data again and again, in that case, introduction of a caching layer is very advantageous. Now if I remove all the animations, my application diagram will look like this. Either from a application load balancer or from API gateway, the inbound request will come either to application or to Lambda function. Both will invoke the read from Redis cluster, and if there is a cache hit, Redis will directly serve that client or serve that request either to application or to Lambda function. And if the data does not exist in Redis, it will go read the data from DynamoDB table, hydrate the Redis cache, and then send the response whatever the application you have used. Either it could be EC2 instance or it could be Lambda function. But the biggest problem here is DynamoDB has read API like get item, batch get item, scan, query. Memcached does not support those APIs. So you can understand there is if you are going to implement that Redis, you have to go through a good amount of application modification. So your application code has to be adjusted accordingly to introduction or to introduce that Redis cluster. So there is a good amount of trade-off between introduction of Redis and the application code modification. So Redis does not support those DynamoDB API. Your application code has to be modified accordingly such that it can support the direct read and write from the Redis cluster, right? So due to this reason, AWS came up with a new offering. I would not say it's a very new offering. It's exists for almost 2 years. This is called DynamoDB Accelerator, or in short DAX. And this DAX offering is specifically to handle the load of DynamoDB table. As per AWS documentation, they are saying it's fully managed, highly available in-memory cache for DynamoDB, and DAX can deliver up to 10 times performance improvement. They have built this DAX offering keeping in mind for DynamoDB use cases. And DAX is just like Romeo Juliet with DynamoDB table. Now, with the introduction of DAX, your application architecture will look like this. Your application load balancer will send the inbound request to EC2. EC2 request, EC2 app will send the read request to DAX instead of DynamoDB cluster. Then if the data exists in DAX, there will be cache hit. It will send that response back to EC2 instance, and EC2 will send that response to application load balancer. In a flip case, if the data does not exist in DAX, it will read the data from DynamoDB table. It will hydrate the DynamoDB table cache. It will hydrate the cache and then send the response back to EC2 instance. Now, for the other use case, similar thing will happen. API gateway will send the inbound request to Lambda. Lambda will read from DAX, and then if the data is available in the DAX cluster, DAX will serve that request directly without invoking DynamoDB. And the good part is that DAX supports get item, batch get item, scan, query this API request. So now you can understand, instead of referring the DynamoDB API or URL, you can directly use DAX URL. And to configure DAX, you have to go to AWS portal or management console. There you can configure the DAX cluster. Although DAX does not have a free tier, so DAX is always paid version, and you can introduce the DAX cluster in front of your DynamoDB table, and you don't have to do any kind of code changes or application modification. That is why AWS say it will work seamlessly. Now let's see different caching mechanism that DAX support. The first technique is read through cache. In read through cache, what your application will do, on the inbound request, application will send the read request to DAX. So for the given key value pair, application will read the data from DAX. If there is a cache hit, that means if the data available in the DynamoDB Accelerator cluster or DAX cluster, DynamoDB Accelerator or DAX will return the data to EC2 instance, and it will not do any DynamoDB query. But if there is a cache miss, in that case, DAX will send the data to DynamoDB table, and DAX will fetch the key value pair from DynamoDB. Then for subsequent read, the key value pair will be populated to DAX cache, and the key value pair will be returned back to application. So you can see, if it's a cache hit, it's a 1 step. If it's a cache miss, this will be 4 step. So for cache miss, there is no advantage, but if there is cache hit, we are getting significant advantage. So for read heavy application, recommendation is to use DAX, and that is why AWS is claiming it can give you 10 times performance improvement. This type of technique is called lazy loading. So whenever your application needs the data will be populated to DAX cluster. This approach has certain advantages and disadvantages. Let's see those. Advantages are, you can see the most recent data will be available to cache. That means in your application, the data that does not required by the application, those data will never be available in DAX cluster, or your DAX cluster will not be overwhelmed with those data, unnecessary data. And you can plan for a relatively low cache size, because your cache will contain only the recent used data. But the disadvantages are, you can see if there is a cache miss, so it will be a 4-step process. It will increase the read latency. So let's say if you have provisioned a low amount of cache size and your application is a read heavy, so that is why what it will do, it can have multiple time cache miss. On the same time, stale data can be available in the cache. Stale data mean maybe your application updated the data to the backend database DynamoDB table, but since the data is served from the DynamoDB cache till the time of time to live or TTL, your application can get a old data instead of getting the new data. So stale data is a big problem for this approach. To overcome this one, the second strategy is write through cache. In write through technique, your application will send the write request to DynamoDB Accelerator or DAX, and for the given key pair application, it will send the write request to DAX endpoint. DAX will write the key value pair to DynamoDB. Upon successful write, DAX cluster will be hydrated with the key value pair, and then DAX will acknowledge successful write to application. So for this approach, we have eliminated that stale data, because whenever you are updating the data into DynamoDB table, your DynamoDB table cluster or DynamoDB cluster or DAX will always have the updated record. You can see the advantage is for read heavy application, you will always get a cache hit, and no pre-cache population is required. There is no stale data also. But disadvantage is it will increase the read latency. You can see it will be a 4-step process for DynamoDB write. Previously, if your application was directly writing to DynamoDB table, now it is writing via DAX. And it may possible that all those unnecessary data may be there in your DAX cluster, what your application might not require. So this approach has some advantage, some disadvantages, and you saw that it increased the read write latency. But from user point of view, we understood that write will always take more time than read. That is why sometimes it is acceptable. The third strategy is write around cache via DAX. So in this approach, your application will directly write the data to DynamoDB, and then DynamoDB, upon successful write, it will hydrate the cache DynamoDB cache with the key value pair, and DAX will acknowledge the successful write to application. So with this approach, it reduces the write latency. But one point you have to remember, there is another one cache strategy called write back or write behind. As of today, May 2021, AWS DAX does not support write back. Let me repeat again. DAX does not support write back or write behind cache. We all know that AWS product feature is evolving very rapidly. Maybe in future they can come with that feature, but as of today, there is no write back or write behind cache for DAX. Now let's see different cache eviction technique. Whenever your cache is overpopulated, the data that you don't need, so the cache cluster, what it will do, it will wipe out that data, and this is called cache eviction. There are 3 techniques. The first technique is TTL or time to live. Here you are setting a absolute time period. Maybe you are setting for 5 minutes. So the data will be available in your DAX cluster only for 5 minutes. In between that 5 minutes, if the data is not referred, then the data will be wiped out. Let's say your application referred some data at 12 p.m. That data was not there in DAX, so DAX populated the data from DynamoDB table, and now that data is available in DAX cluster. You have a 5-minute TTL. In between 5 minutes, that data has not been referenced. Again, on 12:07, maybe the data is referenced. Since that is beyond the time to live, the data will be wiped out from the cache, and again DAX will retrieve the data from DynamoDB. I hope that clarifies the time to live. The second approach is least recently used, and that is applicable when your cache is full. That time DAX will use LRU or least recently used algorithm to evict the item from cache. And the third step is write through. For write through cache, and that is only applicable for write through cache only. For write through mechanism, it will replace the older value with new data with new writes. Now you might be thinking that should I only use DAX Should I not use elastic hash, or do I need to use elastic hash? If you are thinking, then it's a very valid question. My friend, there are different use cases where DAX will be your best choice, whereas there are other use cases where elastic hash will be your best choice. So let me shed some light on that one. If you are using simple key value pair, that means whatever the data you are storing in DynamoDB table, if your application is using the same data without any mathematical processing or without any modification, in that case DAX is your best choice. Again, if there is no mathematical processing, no complex processing, then DAX is the best choice. But if your data requires complex processing, let's say after retrieving the data from DynamoDB table, you have to perform some aggregation, maybe mean, median, maybe grouping. In that case, DAX is not the best choice. DAX will not support that one. For any complex processing to store those aggregated value and all, you have to use Redis. Now hope that clarifies in what use case you should use DAX and in what use case you should use Elastic Hash, Redis or Memcached. With that, I am going to conclude today's session. I hope this was informative for you and you enjoyed. Thank you very much to be with us. My request would be please like, subscribe and share this content. Thank you very much. Please stay safe